Hello everyone. Today we are going to calculate the bearing capacity of a shallow foundation based on a standard penetration test data. So this is the problem, and we need to calculate the net ultimate bearing capacity of the soil mass. So at a site, the ground is non-cohesive, that is, it is a fine sandy bed, and a square footing of size 2 meter by 2 meters. So if you take a footing of size 2 meter by 2 meter embedded into the ground, and the depth of the footing is given to you as 2 meter. Then if SPT is to be carried out at the site for calculating the net ultimate bearing capacity of the soil mass, up to what depth the SPT should be carried out. So as we know that the pressure bulb for this footing from shear criteria will be up to 2 times the width of the footing. So width of the footing B equal to 2 meter. So the zone of influence or the pressure bulb that is going to be effective below the base of the footing, this pressure bulb, this zone is going to be 2 times B, that is 2 into 2 equal to 4 meter. So there is 4 meter, and from the base of the footing up to GL, this is 2 meter. So total depth of exploration equal to 2 plus 4, that is 6 meter. So up to 6 meter SPT must be carried out. And the second part is the SPT N values are recorded, the number of blows required for 30 centimeter penetration of the split spoon sampling tube, and the number of blows at 2 meter onwards up to 6 meter are as given over here. It is 20, 22, 24, 30 and 31. And the groundwater table is here up to the base of the footing. This is the groundwater table. And below this, the saturated unit weight is given to us as 22 kilonewton per cubic meter. And above the groundwater table, gamma T is given as 20 kilonewton per cubic meter, and unit weight of water needs to be taken as 10 kilonewton per cubic meter. Now, once we get the field value, we need to correct it for overburden correction. So we require the overburden correction. So how to correct it? So for correcting, the correction factor Cn is given by this equation 0.77 log of 2000 divided by P naught prime, where P naught prime is the effective overburden pressure at any depth. So you should calculate the effective overburden pressure P naught prime in kilopascal should be calculated, and that is going to be equal to gamma T multiplied by Z. So up to 2 meter, the gamma T is 20, so 20 multiplied by 2, it is going to be 40 kilopascal. Then at 3 meter, it is underwater, so the effective pressure will be 40 plus 1 into 22 saturated unit weight minus 10 unit weight of water, that is 12. So 40 plus 12, it will be 52. Then again at another 1 meter, that is at 4 meter, it will be 52 plus 12. So it will be 64. Then again at 1 meter, that is at 5th meter, it will be 64 plus 12, that is 76, and subsequently plus 12, it is going to be 88 kilopascal at 6 meter depth. So effective overburden pressure has been calculated. Therefore, we can calculate now the correction factor. So correction factor Cn is going to be 0.77, and therefore we can calculate it, the correction factor. The correction factor, if you calculate it, so in 0.77 multiplied by log of 2000 divided by 40, we get 1.30. So here it is 1.3. This is the correction factor. And at 52, we can also find out what is the value at 52 kilopascal. It is 1.22. Then at 64, it is 1.15. Then at 76, it is 1.09, and at 88, it is 1.04. So we are going to get the correction factor. Having got this correction factor, now we can calculate the corrected N value, correction due to N overburden, that is N prime equal to Cn into N. So N is already known to us. So 1.04 multiplied by 31, this value becomes 32.3, we can take it 32. Then 1.09 multiplied by 30, 32.7, let us take it 32. Then 1.15 multiplied by 24 blows, the corrected blows become 27. Then 1.22 multiplied by 22, the corrected blows become 26.8, let us take it 26, and 1.3 into 20, it becomes 26. So this is the first correction to N value. So you can just see how it has been corrected. Now, because it is made of fine sand, and also at 2 meter, the groundwater table is there. So we need to calculate, we need to go for overburden correction. So another correction, overburden due to dilatancy correction. So N double prime. The second correction due to dilatancy. Dilatancy. If it is fine sand and the value is more than 26, more than 15, then you need to calculate. The dilatancy correction is given as N double prime equal to 15, the value should be more than 15, plus 0.5 into N prime minus 15. And if the value are to be corrected only when it is underwater. So let's all correct the value 15 plus 0.5 multiplied by, now N prime is 26 minus 15, it is 11. So this becomes 20.5, let us take it 20. Then this is going to be 20. Then 27, 15 plus 0.5. This is 27 minus 15, that is 12. It is 21. Then the 32 minus 15, that is 17. So 17, it is 23.5. So let us take it 23 and 23. So we have got the corrected value of all this. Therefore, the in the zone of influence, that is from 2 meter from the base up to 6 meter, how many values we have? 1, 2, 3, 4, 5. So let's add up and find out the value. 20, 20, 40. So 40 plus 21, then 23 plus 23, it is 107 divided by 1, 2, 3, 4, 5. So divided by 5, the average value comes out to be 21. So the final average value number of blows is coming out to be 21 blows. So this is the final value. So having got this, you can refer the IS code, and for this there is correlation between the corrected N values, which is 21, and corresponding to this you can find out the angle of friction of the given soil. So angle of internal friction phi for N equal to 21 you can find out from the chart which is given in the IS code, and this comes out to be roughly 34 degrees. So the value of phi having been known, therefore if you refer IS 6403, you have been given a chart where you can find out the value of NQ and N gamma. So here for phi equal to 34 degree, for phi equal to 34 degree, the value of bearing capacity factor NQ is going to be 30, and the value of bearing capacity factor N gamma equal to 40. So these bearing capacity factors will be known to you, and because it is a square footing, you can always find out the shape factor. For a square footing, the shape factor SQ is going to be 1.2, and S gamma, another shape factor, is going to be 0.8 for square footing. You can find out the value of dq and d gamma. dq and d gamma are given by the expression 1 plus 0.1 d by b into tan 45 plus pi by 2, and phi is 34 degrees. So if you calculate, you will get the value as 1.18. So all the values are now known to you, so you can use IS code formula. So IS 6403, you should use it, IS code formula, to calculate the net ultimate bearing capacity of this square footing. So in this problem, in the second part, for calculating the net ultimate bearing capacity of the soil mass, and so we have to calculate net ultimate bearing capacity. So what is the formula? That is known to all of us. So we can make use of the formula, that's Q and U. Let us write the net ultimate. Therefore, the net ultimate bearing capacity of this square footing is given by CNC. Because C is 0, it is, so first term will be 0, need not be considered, plus Q bar into NQ minus 1 Q bar, which is the surcharge, Q and Q, effective surcharge, NQ minus 1, SQ, dq, inclination factor IQ, which is going to be 1, inclination factor, plus 0.5 gamma B N gamma S gamma D gamma I gamma into water table correction factor. This is the formula as per IS code. So here if you substitute the value, what is the effective pressure at the base of the footing? It is 20 multiplied by 2 depth of the footing, so it becomes 40. NQ is already known to us, so it becomes 29 NQ minus 1. Then the shape factor SQ is 1.2 for a square footing, and dq is 1.18. So, and inclination factor is 1 plus 0.5 multiplied by gamma. So gamma is below the base of the footing 22, gamma saturated. B, width of the footing is 2 meter, N gamma is 40 over here, we have already seen, that is, it is 40. S gamma you have already calculated, you have already found out, 0.8. D gamma is 1.18. I gamma inclination factor is 1 into water table correction factor is 0.5 because it is touching the base of the footing. So we will have to calculate in order to find out the net ultimate bearing capacity, which is in this problem. So we can very easily make use of SPT and calculate the net ultimate bearing capacity, net safe bearing capacity, and what is the net load that you can apply. Everything can be calculated. So let us all calculate this. 40 into 29, 1.2, 1.82 plus multiplied by 0.8, 1.18 into 0.5. So the net ultimate bearing capacity I have calculated. This is coming out to be 2057.9. So approximately you can say it is 2058. So approximately this value comes out to be 2058 kilopascal. And if you want to find out the net safe bearing capacity, then net ultimate bearing capacity divided by a factor of safety, which you can take it as 2.5. So if you divide it by 2.5, you get it 823.1 kilopascal. So what is the net safe load that you can apply it? The net safe load that can be applied will be this net safe bearing capacity multiplied by the area of the footing. So area of the footing is 4. So net safe is already known to you, multiplied by 4. So this gives you in kilonewton 3,292.6 kilonewton. The net safe load that this footing can resist. So this is how you can make use of SPT and apply it for calculating the bearing capacity of a footing. Also, you can calculate the settlement. In the next video, we will tell you how to calculate the settlement of the footing. Thank you very much.